Thank you very much for joining our webinar, and I appreciate it that actually you join our this topic of the emergency system fundamental. This is emergency fundamental system is a very important as the human involved. We face a lot of disasters, and facing those disasters, each human being communicate with another human being to just warn them and just communicate with them that okay, there are something wrong, like a flood or earthquake. As the human being is evolved, then our threat level is also, or disaster level is also evolved with the new modern stuff. And with the new, in the new modern system, the human being mostly communicated with another human being either through the speech or the sign. Cover for that one, for the modern system that we have these days, like a mass notification system that is actually a system that provides the information and instruction to a people in a building or space using intelligible voice communication. Or the other system that we are actually using is the emergency communication system, which protect the life by indicating the existing of a emergency situation exist or communicating information to the close by anyone who is stuck in that disaster. Just give me a moment. So before we designing these two systems, mass notification system or the emergency communication system, there are the question arise in our mind, where will be this system will be used, and is it this system is going to be used indoor, or is the system is actually going to be outdoor? What type of a weather system is it? Is it a weather system? If it's a weather system, is it a speaker that is going to be weather resistant? Second is if we are designing for the indoor space, how much a reverberant we actually can understand through the surrounding, the atmosphere. What are the width or height or the length of that system where it going to in that area? And second question always is actually what system you use for it, and what will be this system used for? Like, is it for foreground music, or is it the background music? What kind of a speech level is? Highly intelligible speech level, and what is the clarity that we actually looking for it? How loud will be the system is, and where we going to mount it, the speaker system? And is there any STI level that need to be achieved for those systems? So these are the question that is actually we always looking into our the system design before starting the implementation, the design. So designing a system is actually designing a system after we actually jot down those questions. Then the question is where do we start it? That system is how much sound pressure level expressed in how much a sound pressure level is, and typical dB is like if you are looking for the dB level for the sound pressure is 0 dB to 140 dB, and some are the average listener can hear a 3 dB change in a volume. The perception that the volume level have double is 10 dB. So ideally 10 dB is minimum of what you want to be about ambient in order to hear it clearly. So these, a couple of other questions. This is actually when we are designing the system. So when we threshold the speaker level pressure, then we actually look for the speaker sensitivity. The speaker sensitivity is actually it is about how the speaker is producing a sound, how efficient the sound of a speaker. So that is actually the factor we come with the speaker sensitivity. Most of the time, that is actually we come with the idea that is okay. This speaker can do 90 dB.
John, line 2, sorry.
Sorry. Yep. So sensitivity is 90 dB, which cover the 1 watt for a 1 meter. So that is the mostly high sensitivity is desirable from a most of a less from an amplifier per speaker. So this is the desired sensitivity that is actually we always looking for it. And how much power that we needed to create that speaker level volume. So if you see the example, which is actually, if you see the example here, that is actually, if we make a change of a 3 dB, so we actually need to increase the amplification of a power from 1 watt to 2 watt. And if the speaker is producing 90 dB at a 1 watt, now produce 93 dB at 1 meter. So you see the example. So if the speaker have a good sensitivity, then you need a less amplification power. But if your sensitivity is not very good, then of course you need a higher power of amplification. Second is actually as we are designing, as we see this as the SPL and the sensitivity, the next topic is actually the loss of volume. Loss of volume is actually we can consider is actually if we are a speaker and we go further away from the source where the listener where the audio is coming out, so we actually here this is actually the sound level is decreased. But the question is how much the sound level will decrease. So now the science is tell us that the volume level decrease for conventional speaker by 6 dB for every doubling of its distance. So let's look at our speaker that is producing 90 dB using 1 watt of a power at 1 meter. And if we listen to the speaker on axis at 2 meter distance, the sound pressure level will now be 90 dB minus 6 dB because we need to, because that's the 6 dB that is actually is the difference. So now it's become 84 dB. If we move further to a 4 meter away, the volume will be now 78. So you see that is actually how the physics working in this math calculation, and then you can see that is actually as the distance is further away, then we lose the loss of volume, which is we always measure in a dB over distance. So the question is, why is this important? So we can say that okay, these simple constants like a quick on axis calculation of how loud the volume will be decibel when the speaker has particular distance and amplification at certain wattage. So this is actually important in the design phase. That is actually it gave us the idea that is okay how much amplification I needed if my speaker is actually giving me with the distance. A couple of example, if you're looking for loss of volume, if we actually look for this example, this is a very simple design that is actually it give you the pictorial way that is okay. We have the amplification, and then we have the speaker, which is actually the sensitivity is 90 dB. watt per meter. And if you see that is actually at the 0 meter is giving us the 90 dB. As soon as we moving the distance, as soon as we moving a distance from 0 meter to 1 meter, so as the system, as the speaker sensitivity, we already told that is okay, this is a 1 meter 90 dB. But if we actually go a little bit further, 2 meter, so now the sensitivity for that speaker comes to 84, which is a volume which is 84 dB SPL. And as soon as we are actually increasing the distance, so you will see the difference into a wattage. Now, so every time the distance is actually increased, so we need to double up the amplification. So this is the mathematical calculation that is actually, if you see that is actually, for example, at the 4 meter, which is like a ear level, that is actually how much amplification I needed to people listen a considerable amount of a volume. So we're looking for a 1 watt of a amplification at the 4 meter. I can hear 84 dB. Which, sorry? Can you please mute your phone?
Right,
Please mute your phone, please.
No, it's expensive and money on new nurse call. Yeah.
Please mute your phone, please. Now we are moving to the next important phase is the what happens if the axis is actually off. Like we see the sound pressure, which is the SPL, decrease as we move away from the speaker. So the real question is actually if we are actually moving to if the moving the 6 dB of a speaker from the axis of a 30 degree each side of that one. So what happened to if we're doing the 30 degree? So this is also very important when we're doing for spacing, especially if we are making the speaker into some of a speaker layout arrangement. So we looking this important factor for access. We looking for the SPL, speaker sensitivity, and then we need to know the access. That is actually how much a coverage and how much a distance between each speaker to the another speaker. So knowing the off-axis response of a speaker and amount of even coverage required for the application will determine how many speaker and what the spacing will be between a speaker. The smaller the spacing is between the speaker, the more even the sound level between the speaker. So now we understand that is actually before we designing any system, so we need to know the speaker sensitivity. We need to know the axis of a speaker, and as well as we know the distance. The second question is actually the second question is how and what is the paging system? Because this is the design that is actually we are coming up now is actually the thing is what is a paging system is. The paging system is a public address which is make to announcement or notify the people if they are stuck, like we are already discussed into before starting off a topic that is actually is the system is mass notification system or emergency communication system. So these paging system is kind of a notify or summon to people. These paging system can be in a large building or can be any community center or any community mall for coverage. these is actually key telephone system commonly feature voice over paging, which allow authorized user to page through the intercom system, which works through the speaker built into a telephone set. So most commonly these days is actually every organization you go is a voice over IP system is actually there. So most of a paging system now these days is actually have the requirement that we needed to integrate the phone through phone paging, or the normal phone system can page over to the system. Some are the for these paging system, when we actually designing it, some are the factors that affect the intelligibility, how the speech is actually can clearly we can hear, because speech can be varied by the area of a paging into it. Like if you are paging into a large indoor space as compared to the paging into outside of a space is totally different kind of a experience. And second thing is actually once we doing the paging, so there are a lot of the other factors like a human are walking or they are listening some music. So these are actually creating ambient noise in the system. Now, if we have our ambient noise and we using this kind of a area for the paging, so before we actually considering these areas for a paging, so we need to increase. I mean, these are the factors that affect the intelligibility of a paging. So we can say this is okay. How much we are expected a noise level in a critical situation? How is the is it the in this area that ambient level is constant, or does the level is dramatically change? After ambient noise, then we actually select the speaker. Selection of a speaker because of it is intelligible paging system, so we need to select the right speaker for the right job as per the area. Like if we are actually putting the line array into the mall, or we can do this system with the simple horn system. So why we increase the cost, and we can do the much clear intelligibility with the speaker horn. So these are the considerations that is actually we needed to consider that is okay. We need to know the dispersion angles, the sensitivity, power and distance, and the frequency response. So there are a couple of examples if we are selecting a speaker for our office environment. So dispersion angle is the most important factor. Like mostly the office environment is the ceiling height is mostly is like 10 feet to 14 feet, right? So we need we look for the office is a large open office area, or it is a low ceiling. Or is it the price conscious that is actually we will look, because price is also very important. So for office environment, mostly we actually come up with the idea with the back end and give you a wide version, a wide dispersion area. So this is also the most important thing. Paging speaker system for the warehouse, if you're looking for it. So the most important factor that we looking from a speaker point of view is actually how tall the ceiling is, how tall the racks are. The aisles are narrow or is broader, and then we focus on how much ISPL level that we are required. So the most common speaker that we have is the SC615, which is normally used. Then is actually, now we select the speakers. Sometimes is actually in those offices or warehouses, people require the break the lunch break, or if lunch break is break off, then they need to notify the people that is okay the thing. So you need some kind of a the timer that is actually is one automatically, or it triggered automatically. So or it chimes for the shifts as per our programming design. So you can see that this actually is the our system is TT10, which is like a timer. Work with the EV30R digital message repeater. That is actually tones. It can do the tones or pre-recorded messages at the specific time throughout the day. So there is no human interruption that is actually, it do without any error. The second thing is actually once we pick up a speaker, and then through the speaker what we need to announce throughout the day, and if there is a page, then is actually we need it. Second is how we do the speaker layouts in the warehouse. So if you see, this is actually in this example, we lay out the speaker, and you see that is actually our focus is the dB level is 103 dB level, which is you can see that actually cover the entire the warehouse nicely. So there is a very small variance that is actually you lose any intelligibility. Second, once you pick the speaker and you define the speaker layout, then you need to page. Now the question is where and how you need to page. So page is actually, of course, either you can do through the phone or through the microphone. So we have the page through the microphone or telephone. So the microphone is for all call paging systems, which we have a PM660U. Or if you are actually microphone, that is actually required to select the zone paging. So we do have the product that is actually QRM92. Or is it the something that is actually you want to do the like a telephone or regular or IP phone? Then you can see that's actually that's. Now the second thing is actually this is good for the one single office if the system is within the same system. So you have a microphone, you have a speaker. Now the second thing is actually if the system is a little bit further away, like one building to another building. The question really is how to communicate from one building to another building. If you're running a cable, so of course cost will increase, and within the cost you want to get done the job. So definitely is the easiest and easiest solution that you can do is actually if you have from one building to another building is if you have the network and you want to provide the paging from one campus to another campus, or one building to another building, or one warehouse to another warehouse. So you can do with the network adapter. So you can do with it. With the network adapter you can do from a multiple building to campus. So this what it does is actually it converts your analog audio, which is the paging audio, into packetized into IP format, and then transmit over to your LAN or WAN, whatever it is, and page can be sent all over the building or system. Now, once we actually resolve the issue like distance, SPL, speaker, microphone, one campus to another campus, the second question is arise that is actually, is this page clear to me or is not? So then in a system design, we consider another factor is STI level. So the STI level is actually, for example, let's play this one word, and can we hear it? And the other side of a person that's actually, if you hear it, he says, yeah, it makes sense. If is actually original sound is actually can play, and the other side of a system when it does it, and the other person cannot understand, so it means that is actually the original format cannot be another format. So it means that is actually we have to consider the STI level whenever we are actually designing it. So the STI is actually is each transmission index. It's required how well person understands the spoken language. It is an objective and physical measure of a speech transmission. So STI value is from a 0 to 1 level, which indicates the degree to which the transmission channel degraded speech so the closer more the information is lost. For example, if you have a 0, so it means you cannot understand anything. If you have a 1, it means that is actually is a good thing. So announcements are misunderstood due to a poor system quality, and then tragic consequences may occur. So this is the most important thing that is actually whenever we are designing the system. So in a system that is actually the STI level, we always ask during a design that is actually what is the STI level for that area. And there are the couple of the index that is actually reference guide for the STI level. For example, if you are looking for 0.7 to 1, so we consider as an excellent STI level. If it's a 0.6 to 0.75, so we say fairly good. 0.45 to 0.6 is a fair, and if it's below, if it's a 0 or 0.3, so that STI level is is unacceptable. So you can say this is okay. This is very important system as the STI is becoming more and more common in a job tender, and with the consultant, many designers are now requesting that certain STI level may be met in the facility. The example would be the installation of emergency paging system must obtain a STI level of 0.6 and also must be 10 dB above ambient with SPL uniformity of plus minus 6 dB. The target paging SPL must be 72. So that's important. The question is actually how can we measure the STI before an installation? We do here before designing the system. So we actually put into our simulation system, which is called EASE or EASE-WEG, which allow us to get the STI level based on a room. So we give the full area cover, full area dimension into it, and then the EWEG and the EASE-FOC, EWEG give us a STI level. That's okay. This is a STI level that will actually meet the tender or meet the criteria. In these simulation, we can even we can put more complexity in the system. We can input the room material or ambient noise that allow us to simulate what the environment exactly look like when the speaker layout that will be a design. So this is I mean once we design into a EVAC, it's close to 90 to 97% to the real environment. So this is I can give you the couple of examples that is actually which is like a 100 by 100, 100 by 10 hallway with 12 ceilings. So you can see that is actually STI level, and plus you can see the SPL uniformity between the plus minus 6 dB. So this installation is actually good for the emergency paging system. That is actually must obtain STI level of 0.6 and must also the about the 10 dB ambient. This is another example of a hallway. So you see that is actually this is area that is actually 10 by 100 by 10 feet hallway with 12 feet ceiling with the material of a drywall ceiling with the concrete floor. So the ambient noise now is actually 60 dB. So now we actually require the different speaker layout and the quantity of a speaker. So you can see that there's actually 7 speaker, and you can see the distance version, the dB level. The second question is actually how we actually improve the STI level. We can change or adjust the room environment with the acoustic panel or better material something. Or we can increase the speaker quantity or coverage with the keeping in mind that the dB wattage with the speaker, as we discussed earlier. More speaker at the lesser wattage steps would be the option. Relocate the speaker where you can actually need them. There are, of course, is actually a pro and cons that we need to consider, as well as more likely that is actually because as you increase the more speakers, so of course is actually yes, you gaining one factor that is actually you increase the speaker level, higher STI level, but it increase the cost. So you have to consider in a sense that is actually your cost is maintained, and as well as the quality and STI level. This is another example of a warehouse. That is actually in this warehouse. That is actually you can see that's a couple of points. That is actually we lay the horns, and this is how the speaker layout. That is actually we're using the in this example SC630 TU, and so each software knows how the speaker perform in this space, and the intelligent announcement are possible. So you can see that actually E is actually calculated and measured. That is actually at 113 dB. We can see the speaker dispersion at the 1 watt at the 1 meter. So that's very good so far. Then once we actually design this speaker layout, the second is the office warehouse riser. How the office, for example, the paging system in an office warehouse, how the system looks like. So you can see this is actually the system is actually it's a normal paging system, telephone paging system. The paging is coming through the SIP call. So SIP PBX goes into our one of a mixer 9000, and it is actually not only paging to the office as well as the warehouse and outside. Second is the typical on a paging system into a multi-zone paging example. This is the example where we actually have a couple of the system that is actually we design paging system, how the paging coming into a fitness system, or if it is into a car. So it's like a multi-zone paging system. So page is started from a head and it can be announced, or it can announce into all system seamlessly. For emergency paging system, we do most ideal product that is actually which is UL certified 2574 or ULC S576 compliant. That's VM system, very robust system, 3240, small to medium application, office building, industrial, and shopping center. Can be extendable to 6 zone to the 60 zone. So you can see that is actually once you design the system, before designing the system is very important that is actually the system should be modular or expandable in the future, if there is. And this system, when we design it, it is also important that is actually failover in any designing. For example, if there is a one weak link in a system, for example, power is outage, so system still should be, should provide the, the announcement without loss of a power. So this system can be backup power, speaker line supervision. Plus is actually, if you see the feature of this product, VM3240, so it has the front panel mic emergency use, and it does have the 240 watts share over to a 6 speaker output. Each speaker can be attenuated override. You can, in this system, you can add the two remote input RM. This system has a 3 XLR plus TRS mic and line. You can add also a 2 BGM inputs into it, and you can record out. And it can be 24 volt DC. You can port for a backup. AC is the main primary power, but you can run also a 24 volt. You can monitor this system through the TCP, which is LAN or network, any network that you have, and you can program it or you can monitor this system. If you see the system graphical interface is very user friendly. You just plug and play, and plus drag and drop kind of a system. So it's actually you just design it, and it's very user friendly. So this is actually you can create the system in a first page, and then you can create the zones and bed zones. Then you can create the priority of each zone, which input, what priority you have, and then each event you can then assign the different events with the different priority. Then we can see this is actually this is the typical example of this system, a typical education school system. That is actually how this system can be utilized. Like if you go for outside area or if in a classroom, so we can have these, you can go with the ceiling speaker, and plus you can not only have the fireman mics, but you can integrate the other microphones into it. And plus you see the this is very versatile in that one. Another application for this system, if you see, is the grocery store, where you can easily integrate this system in a grocery store. This is another one that is actually example of a hotel. You can see that is actually how we actually using the system into a different application with the different areas. Now the question is actually one floor, second floor, third floor, and the parking zone. So these are the couple of applications. Now these applications, if this is actually the next hurdle for designing a system is, if this system is actually from one building to another building, how we communicate it. So we actually, last time, previously we discussed about it, that is actually we have the network adapter to communicate it one system to another system. So the question really is this system can take the audio paging from one campus, network overlay to a network, and then paging to the other campus. So in this example, we can see is the a typical example that is actually we interconnect with the NX 100. You can see that is the from building D to building B or building E to building C, and from the the security or the admin side. So seamlessly, it is interconnected, seamlessly paging from one building to another building over the network. So it can be done through the our product line NX 100. A couple of the systems that is actually for voice evacuation and mass notification system. You need to consider that is actually is URL rated or not. So we have a wide variety of a system for the different application and different areas. So we have for office environment is the PC580 or ST630 TU horns or boxes speaker is all UR. So you have the more flexibility, or if you are looking for a pendant or the wide large horns or ceiling speaker. So we have the wide range of a speaker.